Hello students, welcome to EC Engineering. In this video, we will discuss about the port diagram with one example problem and how to draw the port diagram and what are all the steps included and the way to obtain gain and phase crossover frequency also examined in this problem with a given example. So, as per the question given, the first exercise with a port diagram is plot the port diagram for the following transfer function and obtain gain and phase crossover frequencies. Given transfer function is G of S equal to 10 by S into 1 plus 0.4 S into 1 plus 0.1 S. So, proceed with the solution part. See students, keep it in your mind, in a port diagram we need to draw two diagrams via magnitude plot and the second one phase plot. The first one we proceed with magnitude plot. So, in step 1, substitute S is equal to j omega in a given transfer function. So, the given transfer function is written in a port form by substituting S is equal to j omega. Then find corner frequencies. So, corner frequencies, see here, real part divided by imaginary part, 1 divided by 0.4 gives you 2.5 radian per second. Here corner frequency 2, 1 by 0.1 equal to 10 radian per second. So, proceed the second step with the tabulation filling terms. First, corner frequencies, slope and change in slope dB per decade. dB per decade. So, now, we discussed in the last video that the first term made with constant or integral form. Here we have 10 by S. So, this is our first term. Then, as per the increasing order of a corner frequency, we have to make second and third term. So, your first term becomes 10 by S or 10 by j omega. Then second term in the increasing order of a corner frequency. So, 2.5 corner frequency term first comes second term, then 10 radian per second corner frequency term comes as a third term. So, for each S we have a minus 20 dB per decade of slope. So, one single S term in a denominator, see here denominator 1 S term, j omega term, here denominator 1 j omega term, here also 1 j omega term. So, the slope becomes minus 20, minus 20, minus 20. Then change in slope. Here there should not be change in slope, this is a first term. So, put it over dash. So, the change in slope is the difference between the previous slope and the next slope. So, minus 20, change. So, minus 40 dB per decade. The next slope, see taken minus 40, then here minus 20, minus 60 are third term change in slope. Likewise, we have to fill the tabular column for magnitude plot. Then proceed with step number 3 and 5. So, in step number 3 and 5, we have to find the low frequency omega L and high frequency omega H. So, low frequency should be lesser than first corner frequency and the high frequency should be greater than second corner frequency. So, accordingly, we have to choose 0.1 radian per second. Why? Because our omega C1 is 2.5 our omega C2 is 10. So we just choose one value lesser than 2.5 as 0.1 and we choose one more value higher than second corner frequency, that is higher than 10, we made it as an 50 here. Then step number 4. In a step number 4, we need to calculate gain A at 4 frequencies of omega L, lowest frequency, then omega C1, omega C2 and omega H. Now find at omega equal to omega L, means here omega L is 0.1. So A equal to gain equal to 20 log 10 by j omega term. So in this omega you put it over 0.1. See, it's a modulus of, so irrespective modulus we know j term, complex term. So while substituting 20 log 10 by 0.1, you will make it in a calculator, you will get 40 dB. Then A equal to 20 log 10 by j omega or 10 by 2.5 is 12 dB per dB. Accordingly, we calculated gain for two frequencies, lowest frequency and then corner frequency 1. Then as per the procedures discussed in the last video, we are well known that how to calculate the change in slope frequencies at an for an gain A. So A equal to, for omega C2, as per a given problem it is 10. So A equal to slope from omega C1 to omega C2 with an changes takeover from corner frequency 1 to 2 and log omega C2 by omega C1 into A at omega equal to omega C1. We are all well known that gain at omega equal to omega C1 is 12 dB. So substitute here 12 dB. Then slope from omega C1 to omega C2. So slope from omega C1 to C2 is, omega C1 to C2 is minus 40 degree, 40. So here you put it over minus 40 into log omega C2 value 10, omega C1 value 2.5, 10, 2.5. Substitute here and now we find gain at omega equal to omega C2 is minus 12 dB. Accordingly, for omega equal to omega H means 50. Slope from omega C to omega H into omega H by omega C2 plus A at omega equal to omega C2. So this is what we found in the last step, that is minus 12 dB. It is minus 12 dB. Then log omega H by omega C2, obviously 50 by 10. And here slope from omega CH to omega H is, so in the last term, minus 60. So is minus 60. Substitute the values over in a calculator and we find omega to omega H is minus 54 dB. Now I will explain you how to draw magnitude plot, first plot. So what we have 4 frequencies via omega L, omega C1, omega C2 and omega H, correspondingly the value of gains, corresponding values of gains. So all these 4 points we need to debit over in a magnitude plot. So for drawing an, observe here, for drawing an magnitude plot, take logarithmic scale here, logarithmic scale here. So here it's a logarithmic scale value. It's a linear scale value. So here these values are gains in dB. Then these are all the logarithmic scale values. Now observe the values and try to fix the axis. R values are varies from 0.1 to 50. 0.1 to 50, and gain values from 40 dB plus to minus 54 dB, plus 40 to minus 54 dB. So that's why here we have chosen 0.1 here, 0.1, 0.2, 0.3, 0.4, similarly here omega value 1. If you consider it as 1, then 2, 3, 4, 5, 10, then 20, 30, 40, 50 up to 100. Similarly it goes on. So but here we need only the values from 0.1 to 50 only. So where is 50? Here is 50. So accordingly we have to scale the values. So these x-axis values are same throughout the magnitude as well as an magnitude plot, and gain. So here gain we need both positive values and negative values. Now I am choosing an 0 reference value, then plus 10, plus 20, 30, 40 plus values above 0 line, then minus 10, minus 20, minus 30, minus 30, minus 40, minus 30, minus 40 in below 0 value. Now we'll see how to point the values. See what we require here for 0.1 omega 40 dB. So coming back here for 0.1 omega 40 dB plus value, and mark it here and circle it. Then 2.5 12. So here 1, here 2, here 2.5. So 2.5, then your omega value 2.5, and 12, positive 12. See here positive 12 for gain value. Then third value 10 minus 12 dB. So 10 here is 10 and minus 12 value here, 10 minus 12. Then the fourth one 50, 50 minus 54. So here, here 50 and minus 54. This point. Hope you can see 50, 54, and join all the points using scale as a straight line. So the first one is minus 20 dB per decade, which is already we put it in a tabulation side. Then this slope is minus 40 and this slope is minus 60 dB per decade. And the scale for the first one magnitude plot is x-axis 1, y-axis 1 unit equal to 10 dB. 10 dB that we can make it out. Then I will explain you how to draw the phase plot. So for drawing and phase plot, first consider the equation, Bode form equation, and write the phase angle equation. See here we have one S term in a denominator, so minus 90 degree. Then this term, tan inverse of 0.4 by 1 or 0.4 omega. This term, tan inverse of 0.1 omega. The similar cases, how we can proceed in a polar plot. The same procedure. So next to tabulate the values in order to find the various values of phase angle. We already have a crossover frequency as well as an omega L, omega H values are omega C 2.5, omega C 210, omega L 0.1, omega H 50. Along with these four frequencies, we have to choose some other frequencies in order to have an various points for drawing a graph. So that minimum value is here 0.1, so take a minimum value. Then next to the minimum value is 2.5, so in between I am choosing 1. The next value is 10, so in between 2.5 and 10 I am choosing 4. Not must be 4, you can choose 5 also, but in between you can choose either one of the highest value, either one of the values, simply saying. Then 10 and 50, so in between 10 and 50 I am choosing 20. So what are all the terms included in this phase equation? For phase equation I am having tan inverse of 0.4, tan inverse of 0.1, all these values with minus 90 degree. So what I am doing is, for an ease of convenience, I am first taking an tan inverse of 0.4 calculation for all the frequency, means omega values. Then tan inverse of 0.1 omega values. Then after I do calculate this minus 90 degree minus this value minus this value. It is easier to calculate a phase angle in a calculator side. Similarly, I do the calculations in a calculator, which is approximately equal to minus 92 degree. I do the approximation here one by one. So these are all the values I got it from an calculations through an calculator. So for an ease of convenience, I am doing a tan inverse of 0.4 omega, tan inverse of 0.1 omega for an ease of convenience. Directly substituting make much complications. That's why I do these two columns calculations. Now we will proceed with a phase plot. So for plotting and phase plot, we need these omega values and these phase angle values. See, our omega values are from 0.1 to maximum 20. Say why I ignore 50 here means we attain 180 values in between here only, 170, 1 to 10. So no need for to proceed 20 and 50 also, but even I calculated, that's why I debit over. No need to go for frequencies beyond minus 180 degree. See here angle also minimum 92 degree, maximum 236 minus values. So for doing an phase plot, I choose right side y-axis value for phase angle. So before that, see here I am choosing minus 60, minus 80, minus 100, minus 120, accordingly up to minus 240. So y-axis 1 unit for phase plot is minus 20 degrees, minus 20 degrees. And the omega values are considered as it is. How we proceed with the magnitude plot? 0.1, 1, then 10, 100 similarly. Now coming back to, so what is the value given here? 0.1 and minus 92. 0.1 minus 92. See here, observe clearly, here 80, here 100. So in between 90 or approximately choose this point as a minus 92. This minus 92 for 0.1 value. 0.1 value. Similarly, for next value 1 minus 118. Where is one value? Here one value. Where is minus 118? Above minus 120, 118, 1. And third point 2.5 minus 150. See here minus 150, then it is 1, here 1, so this is 2 and this is 3, in between 2.5. Similarly, I do for 4, 10 and 20. 4, so for 4 I have minus 170, for 10 I have for minus 210, for 20 it's minus 236. Similarly, I put all the values of omega in a plot and join it as a freehand drawing. Keep it in your mind, magnitude plot using scale, and I am writing here as a magnitude plot. It's a freehand drawing phase plot. Phase plot. Then what is asked in a question? In a question we are asked to find phase crossover frequency and gain crossover frequency. If you are familiarized with the drawing and magnitude and phase plot, it is very easier for us to find magnitude and from a magnitude plot gain crossover frequency, from a phase plot phase crossover frequency. See here how to find the magnitude from a magnitude plot gain crossover frequency. Simply take a reference 0, make a dotted line. So in the dotted line of reference, where it cuts the magnitude plot, the corresponding frequency is a gain crossover frequency. Accordingly, see here it's a 0 reference value. We make a tracking and it cuts the magnitude plot at one particular point. The corresponding value of an frequency is 5. So the gain crossover frequency is 5 radian per second for the given problem. Then through the phase plot. So in a phase plot you just observe minus 180 degree. So the minus 180 degree of a value where track the point where it cuts the phase plot, the corresponding frequency is an phase crossover frequency. Here is 5 radian per second. Could you understand? 180 degree. We track the dotted line where it cuts the phase plot, the corresponding omega value is an phase crossover frequency. So from this plot, according to the asked question, we found gain crossover frequency is 5 radian per second and phase crossover frequency also 5 radian per second. Students, hopefully you can understand the problem, I think so, and do practice with these things, and rest of the examples also I posted in a further videos. And keep share and do like. If you want to comment anything or any clarifications regarding, you post it in a comment section. Thank you students. Thanks for a good sharing.